it's observed that a lighting panel is supplied from a 3-wire busway that lacks a neutral connection, and the panel is currently using ground as a neutral. The question of running a separate neutral from the main distribution panel, approximately 350 feet away, to the lighting panel is considered. Using the ground as a neutral is not a safe or code-compliant practice. Running a separate neutral addresses this concern. A dedicated neutral wire provides a lower resistance path for current return, resulting in improved voltage stability and reduced voltage drop. Using the ground as a neutral creates potential shock hazards due to unbalanced loads. A dedicated neutral eliminates this risk. Running a separate neutral over a significant distance, specifically 350 feet, will require additional conduit wiring and labor. If the neutral wire is disconnected or damaged, it can result in open circuits and electrical faults. The neutral wire needs to be properly sized and protected, and it may require additional maintenance over time. Alternative options include installing a 3-phase transformer. This would provide a neutral connection to the busway and eliminate the need for a separate neutral run. However, this may be more expensive and require additional space. Using a neutral ground resistor, or NGR, is another option. This device provides a path for neutral current to return to the source through the ground, mitigating the issue of grounding the neutral. However, NGR require proper sizing and may not be suitable for all applications. Running a separate neutral from the main distribution panel is a feasible solution to resolve the grounding issue and improve electrical performance. However, the cost, effort, and potential maintenance concerns should be carefully considered. It's advisable to consult with a qualified electrician or engineer to assess the specific requirements, costs, and alternative options before making a decision. When dealing with electrical systems, it's crucial to adhere to the National Electrical Code, or NEC, and local regulations. Several articles within the NEC address grounding and neutral conductor requirements. For example, NEC Article 250 covers grounding and bonding, providing guidelines for ensuring electrical safety and minimizing the risk of electrical shock. NEC Article 310-15 discusses opacity of conductors, which is crucial when sizing the neutral conductor to ensure it can safely carry the anticipated current. NEC Article 408 covers switchboards and panel boards, outlining the requirements for their installation and use. When determining the appropriate size for the neutral conductor, several factors must be considered. Firstly, the expected load in the lighting panel needs to be accurately calculated. This includes determining the total amperage drawn by all the lighting fixtures connected to the panel. Secondly, the NEC provides guidance on neutral conductor sizing based on the type of load and the presence of nonlinear loads. Nonlinear loads, such as those found in electronic ballasts used in some lighting systems, can generate harmonic currents that increase the current flowing through the neutral conductor. Thirdly, voltage drop calculations are essential to ensure that the voltage at the lighting panel remains within acceptable limits. A properly sized neutral conductor minimizes voltage drop and ensures that the lighting fixtures receive adequate voltage. When running the neutral conductor, it's important to select the appropriate wiring method and conduit. The NEC specifies acceptable wiring methods for different applications, and the chosen method must comply with these requirements. Conduit provides mechanical protection for the conductors and helps to prevent damage from physical stress or environmental factors. The conduit must be properly sized to accommodate the conductors and any necessary grounding conductors. Grounding is a critical aspect of electrical safety. The grounding system provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices, such as circuit breakers, to trip and energize the circuit. This helps to prevent electrical shock and minimize the risk of fire. The grounding conductor must be properly sized and connected to the grounding electrode system, which typically consists of ground rods or a metal water pipe. When installing a separate neutral conductor, it's essential to ensure that it's properly identified and labeled. This helps to prevent confusion and ensures that electricians can easily identify the neutral conductor during future maintenance or repairs. The NEC requires that neutral conductors be identified with a white or grey color. In addition to the NEC, local electrical codes and regulations may also apply. These codes may have additional requirements or restrictions that must be followed. It's important to consult with the local electrical inspector to ensure that the installation complies with all applicable codes. When considering alternative options such as installing a three-phase transformer, several factors must be evaluated. The transformer must be sized appropriately to handle the load of the lighting panel. The transformer's voltage rating must also match the voltage of the busway and the lighting panel. Additionally, the transformer must be installed in a location that meets the NEC requirements for ventilation and accessibility. Neutral ground resistors, or NGRs, offer another alternative for addressing grounding issues. An NGR is a device that's connected between the neutral point of a transformer or generator and ground. It limits the amount of fault current that flows during a ground fault, which can help to protect equipment and reduce the risk of electrical shock. However, NGR require careful sizing and coordination with the overcurrent protection devices in the system. The selection of an NGR depends on several factors, including the system voltage, the available fault current, and the desired level of protection. Furthermore, the installation of an NGR must comply with the NEC and the manufacturer's recommendations. When evaluating the feasibility of running a separate neutral conductor, it's important to consider the potential impact on the existing electrical system. The addition of a neutral conductor can affect the impedance of the system, which can impact the performance of overcurrent protection devices. It's also important to ensure that the neutral conductor is properly bonded to the grounding system to maintain electrical safety. The bonding connections must be made in accordance with the NEC requirements. In some cases, it may be necessary to perform a short-circuit study to determine the impact of the new neutral conductor on the system's fault current levels. A short-circuit study can help to identify potential problems and ensure that the overcurrent protection devices are properly coordinated. The installation of a separate neutral conductor can also affect the voltage balance in the electrical system. If the loads on the lighting panel are not evenly distributed across the three phases, it can create an unbalanced voltage condition. An unbalanced voltage can lead to overheating of motors and other equipment, as well as reduce efficiency. To minimize voltage imbalance, it's important to distribute the loads as evenly as possible across the three phases. It's also important to periodically monitor the voltage balance in the system and make adjustments as needed. In addition to the technical considerations, it's also important to consider the economic aspects of running a separate neutral conductor. The cost of materials, labor, and permitting can be significant, especially for a long run of 350 feet. It's important to obtain accurate cost estimates from qualified electricians and contractors before making a decision. It's also important to consider the potential long-term benefits of running a separate neutral conductor, such as improved electrical performance and reduced risk of electrical hazards. These benefits can help to offset the initial cost of the installation. When working with electrical systems, it's crucial to follow safe work practices. Always to energize the circuit before working on it and use appropriate personal protective equipment such as safety glasses and insulated gloves. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. Electrical work can be dangerous, and it's important to take all necessary precautions to ensure your safety. Always double-check your work to ensure that all connections are tight and that all components are properly installed. A mistake can have serious consequences. In conclusion, running a separate neutral conductor to the lighting panel is a feasible solution, but it requires careful planning and execution. It's important to consider the technical, economic, and safety aspects of the installation before making a decision. Consulting with a qualified electrician or engineer is highly recommended to ensure that the installation is done correctly and safely. Remember to always follow the NEC and local electrical codes to ensure compliance and safety. These codes are designed to protect people and property from electrical hazards. It's also important to keep accurate records of all electrical work that's performed. These records can be helpful for future maintenance and troubleshooting. They can also be used to demonstrate compliance with electrical codes. Regularly inspect your electrical system for any signs of damage or wear. Look for frayed wires, loose connections, and damaged components. If you find any problems, have them repaired immediately by a qualified electrician. Ignoring electrical problems can lead to more serious issues, such as electrical fires. Electrical safety is everyone's responsibility. By following safe work practices and taking the necessary precautions, you can help to prevent electrical accidents and ensure the safety of yourself and others. Consider the long-term implications of any changes to your electrical system. A well-designed and properly installed electrical system can provide reliable and safe power for many years to come. A poorly designed or improperly installed system can lead to problems and hazards. Make sure to choose qualified electricians and contractors who have the experience and expertise to do the job right. Check their credentials and references before hiring them. Don't be afraid to ask questions and get multiple bids. The additional effort can pay off in the long run. Remember that electricity is a powerful force. Treat it with respect and always follow safe work practices. With proper planning, installation, and maintenance, you can ensure that your electrical system is safe, reliable, and efficient. Keep learning about electrical safety and technology. The more you know, the better equipped you'll be to make informed decisions about your electrical system. There are many resources available, such as online courses, trade magazines, and industry conferences. Take advantage of these opportunities to expand your knowledge and skills. Consider the environmental impact of your electrical system. Choose energy-efficient lighting and appliances to reduce your energy consumption. Recycle old electrical equipment properly to prevent pollution. Be a responsible steward of the environment and help to conserve resources. Staying informed about the latest electrical technologies and best practices can help you make informed decisions about your electrical system and ensure its safety and efficiency. Consider the future needs of your electrical system. As your needs change, you may need to upgrade your system to accommodate new equipment or increased loads. Plan ahead and consult with a qualified electrician to ensure that your system is prepared for the future. Regular maintenance is essential for keeping your electrical system in good condition. Schedule regular inspections and testing to identify any potential problems before they become serious. A well-maintained system is a safe and reliable system. Don't neglect the importance of surge protection. Surges can damage electronic equipment and cause fires. Install surge protectors at the main electrical panel and at individual outlets to protect your valuable electronics. Ground fault circuit interrupters, or GFCIs, are essential for protecting people from electrical shock. Install GFCIs in bathrooms, kitchens, and other areas where there is a risk of water contact. GFCIs can save lives. Arc fault circuit interrupters, or FCIs, are designed to protect against electrical fires caused by arcing faults. Install FCIs in bedrooms and other areas where there is a risk of fire. FCIs can prevent fires and save lives. Never overload electrical circuits. Overloading can cause wires to overheat and start a fire. Use a circuit analyzer to determine the load on each circuit and make sure that it doesn't exceed the circuit's capacity. Be aware of the potential hazards of aluminum wiring. Aluminum wiring can corrode and loosen over time, which can create a fire hazard. If you have aluminum wiring, have it inspected by a qualified electrician and consider having it replaced with copper wiring. Use caution when working around overhead power lines. Maintain a safe distance from power lines and never touch them with any object. Power lines can carry thousands of volts of electricity and can be deadly. If you're planning any digging projects, call your local utility company to have them locate any underground utilities. Digging into underground utilities can be dangerous and can disrupt service. Be prepared for power outages. Have a backup power source, such as a generator, and keep flashlights and batteries on hand. Power outages can be inconvenient and can disrupt your life. Have a plan in place to deal with power outages. Remember that electrical safety is a continuous process. Stay informed, be vigilant, and take the necessary precautions to protect yourself and others from electrical hazards. By following these guidelines, you can help to ensure that your electrical system is safe, reliable, and efficient. Don't hesitate to seek professional help when needed. A qualified electrician can provide valuable advice and assistance with any electrical issues. The electrical work is best left to the professionals.